Let's dive into one of the most violent and awe-inspiring events in the universe: gravitational collapse. At its core, gravitational collapse is a cosmic squeezing process. It happens when a star's own gravity finally wins a lifelong battle against the heat and energy inside it. When that balance is lost, the star can no longer hold itself up, and it implodes, shrinking into something extraordinarily dense, like a neutron star or a black hole. To understand why a star collapses, we first need to understand how it survives for billions of years in the first place. Imagine a giant hot air balloon. The hot air inside pushes outward, keeping the balloon round and floating, while gravity and air pressure try to pull it down. As long as the hot air keeps flowing, the balloon stays inflated. A star works in a very similar way. It exists in a constant balance between two opposing forces. Gravity pulls all the star's matter inward, trying to crush it toward the center. At the same time, nuclear fusion in the core pushes outward. By fusing hydrogen into heavier elements, the star produces enormous amounts of heat and radiation. This outward pressure acts like a stop sign for gravity. As long as the star has fuel to burn, this balance holds. But fuel does not last forever. In massive stars, nuclear fusion follows a predictable path. First, hydrogen is fused into helium, then helium into carbon, and heavier elements after that. This process continues until the star begins producing iron, and iron changes everything. Fusing iron does not release energy. Instead, it consumes it. The moment iron builds up in the core, the outward pressure that once supported the star suddenly shuts off. It's like the heater inside the hot air balloon instantly dying. With nothing left to hold it back, gravity wins immediately. Now, the real squeeze begins. The star's gravity is unimaginably strong. Its outer layers collapse inward at speeds reaching about the quarter of the speed of light. The pressure becomes so intense that atoms themselves are destroyed. Electrons and protons are forced together, forming neutrons. A core that was once the size of Earth is crushed into a sphere only a few kilometers across, roughly the size of a small city. Matter is packed so tightly that a single teaspoon would weigh billions of tons. What happens next depends on how massive the star was to begin with. In many cases, the collapsing outer layers slam into the ultra-dense core and rebound violently. This rebound triggers a massive explosion known as a supernova. The explosion blasts the star's outer material into space, while the crushed core remains behind as a neutron star. But if the star is truly enormous, even neutron pressure is not enough to stop the collapse. Gravity continues squeezing matter beyond any known physical limit. Space and time themselves bend inward, and matter collapses into a point with no volume and infinite density. A black hole is born. In the end, gravitational collapse is the literal crushing of matter into extreme states where the laws of physics begin to break down. It's the transformation of a shining star into either a dense stellar corpse or a bottomless gravitational abyss. A dramatic end to a brilliant cosmic life.